Welcome to G Fun Facts Online. High above the verdant, seemingly endless expanse of the Amazon rainforest, a colossal, invisible phenomenon is at work. Imagine a river larger than any on Earth, flowing not across land, but invisibly through the sky. This isn't science fiction. It's a real phenomenon happening right now over the Amazon, shaping the climate of an entire continent. These are the flying rivers, and they are in mortal danger. Today, we delve into how the world's largest rainforest creates these atmospheric arteries, and why it's teetering on a catastrophic tipping point that could change our world forever. The concept of flying rivers poetically describes the immense movement of water vapor from the Amazon basin to other parts of South America. These aerial rivers are a cornerstone of the continent's hydrological cycle, a complex system that begins thousands of miles away over the Atlantic Ocean. Moisture-laden winds from the ocean are drawn inland, where they encounter the vast expanse of the Amazon rainforest. Here, the forest acts as a gigantic water pump. The nearly 390 billion trees in the Amazon release enormous quantities of water vapor into the atmosphere through a process called transpiration. An average-sized tree can release hundreds of gallons of water into the air each day. In fact, the Amazon rainforest is so efficient at this process that a given area of the forest can evaporate up to 8 times more water than the same area of the ocean's surface. This transpired water, combined with the moisture from the Atlantic, creates massive, moisture-rich air masses. On any given day, the Amazon rainforest releases an estimated 20 billion tons of water vapor into the atmosphere. To put this staggering figure into perspective, it is a volume greater than the daily discharge of the Amazon River, the world's largest river by water flow, into the Atlantic Ocean. These colossal rivers of vapor are then transported by prevailing winds, generally flowing westward across the Amazon basin. This journey is not a simple one-way trip. The moisture is recycled multiple times, with water evaporating, forming clouds, and falling as rain over the forest, only to be taken up by the trees and transpired back into the atmosphere. This process can repeat 5 to 6 times before the air mass reaches the Andes Mountains. The towering Andes act as a natural barrier, redirecting these massive flows of humid air. A portion of the moisture surmounts the mountain range, bringing rain to western Peru, but the majority is diverted southwards. This southward flowing atmospheric river then delivers life-giving rain to vast regions of central and southern Brazil, Paraguay, Uruguay, and northern Argentina. These rains are vital for agriculture in what is known as the breadbasket of South America, and they replenish the water reserves of major urban centers. Some of this moisture even travels as far north as the Midwestern United States, influencing rainfall patterns there. The term flying rivers, popularized by scientist Dr. Jose Marengo, aptly captures this large-scale atmospheric transport of water vapor. The discovery and understanding of flying rivers have been advanced through initiatives like the Flying Rivers Project, started in 2007 by Swiss-Brazilian pilot Gerard Moss in collaboration with scientists. By collecting water vapor samples during flights over the Amazon, the project has provided crucial data to evaluate the origin of atmospheric water and underscore the Amazon's role as a source of this vital resource. But the very system that generates these life-sustaining flying rivers is now under severe threat. The Amazon rainforest is approaching a critical threshold, a tipping point, beyond which it could irrevocably transition into a drier, savanna-like ecosystem. This process, often referred to as savanization or dieback, would not be a sudden event, but a gradual degradation that is already being observed in some areas. A tipping point, in this context, is a critical threshold where a small change can trigger an abrupt and often irreversible shift in the state of an ecosystem, accelerated by feedback loops. For the Amazon, this means that the combination of deforestation and climate change-induced stress could push the rainforest beyond its capacity to sustain itself. Scientists have long warned about this possibility, with some of the pioneering work being done by Dr. Carlos Nobre. Research suggests that the tipping point could be triggered if global temperatures rise by 2 to 4 degrees Celsius, or if 20% to 25% of the Amazon rainforest is deforested. Alarmingly, around 17% to 20% of the Amazon has already been cleared, placing the ecosystem perilously close to this critical threshold. The mechanism behind the tipping point is a dangerous feedback loop. As the forest is cleared, there are fewer trees to transpire water, leading to a reduction in rainfall. This drying effect is exacerbated by climate change, which is projected to increase temperatures in the Amazon by 2 to 3 degrees Celsius by 2050 and cause more frequent and severe droughts. The drier conditions, in turn, make the forest more susceptible to fires, which are often intentionally set to clear land for agriculture and cattle ranching. These fires release massive amounts of carbon into the atmosphere, further accelerating global warming, which then leads to more drying of the forest. This vicious cycle pushes more of the forest towards a state where it can no longer support a lush, humid rainforest ecosystem and begins to transform into a drier, open canopy savanna. Recent studies have painted a grim picture. A 2024 paper published in Nature by a team of international scientists concluded that by 2050, as much as 47% of the Amazon could reach a tipping point, leading to large-scale ecosystem transitions. Another study found that some parts of the Amazon, particularly in the eastern region which has lost 30% of its forest cover, have already switched from being a carbon sink to a carbon source, meaning they now emit more carbon dioxide than they absorb. The primary forces pushing the Amazon towards its tipping point are deforestation and climate change, two interconnected threats that feed off each other. The clearing of the Amazon rainforest is driven primarily by the expansion of agriculture, particularly cattle ranching and soy cultivation. Logging, both legal and illegal, also contributes significantly to forest loss. The construction of roads and other infrastructure projects opens up previously remote areas to deforestation. While there has been some positive news regarding deforestation rates in the Brazilian Amazon, which have seen a significant decline in 2023 and 2024, the threat is far from over. Despite these recent reductions, the accumulated loss of forest cover remains a major concern. Furthermore, while outright deforestation may be slowing in some areas, forest degradation from factors like selective logging and fires is on the rise. One report indicated a nearly 500% spike in degradation in 2024 compared to the previous year, largely driven by an increase in wildfires. The impact of deforestation on the water cycle is direct and devastating. When the forest is cleared, the land loses its capacity to recycle moisture. Instead of being returned to the atmosphere through transpiration, more than half of the rainwater runs off, diminishing the flying rivers and leaving downwind areas with less rainfall. The smoke from fires used to clear land also releases particles into the atmosphere that can suppress rainfall. At the same time, global warming is exacerbating the threats to the Amazon. Rising temperatures and changing rainfall patterns are leading to longer and more severe droughts. The Amazon has experienced once-in-a-century droughts multiple times in the last 2 decades. The severe drought of 2023-2024, amplified by the El Niño phenomenon, had a devastating impact on the region. Warmer temperatures and drier conditions create a tinderbox effect, making the forest highly vulnerable to fires. These fires, once a rare occurrence in the humid rainforest, are becoming more frequent and intense, contributing to a vicious cycle of degradation. Interestingly, some recent research has shown a surprising resilience in the remaining intact forests. A study found that trees in the Amazon have been growing larger, with their trunks thickening by an average of 3.3% each decade. This is attributed to the fertilizing effect of higher carbon dioxide concentrations in the atmosphere, which can stimulate plant growth. However, the researchers caution that this effect may not last, as the negative impacts of heat and water stress are expected to increase. The savannization of the Amazon would trigger a cascade of devastating consequences, with impacts felt locally, regionally, and globally. First, on regional climate and water security, the weakening or collapse of the flying rivers would have a catastrophic impact on the climate and water resources of South America. Regions that depend on the rainfall generated by the Amazon, including the agricultural heartlands of Brazil, Argentina, Paraguay, and Uruguay, could face a dramatic reduction in precipitation, potentially by as much as 44%. This would lead to severe water shortages for agriculture and urban populations, threatening food security and economic stability. The very regions that produce a significant portion of Brazil's GNP could be transformed into arid landscapes. Second, biodiversity loss. The Amazon is the most biodiverse region on the planet, home to an estimated 10% of the world's known species. The transition to a savanna would lead to a mass extinction event, with countless species of plants and animals unable to adapt to the drier, hotter conditions. Species that depend on the dense forest canopy, such as many primates, could lose vast portions of their habitat, while some species from adjacent savanna biomes, like the Cerrado, might expand their range into the transformed Amazon. The overall loss of unique rainforest biodiversity would be immense and irreversible. Third, global climate impacts. The Amazon rainforest plays a crucial role in regulating the global climate by storing vast amounts of carbon. It holds an estimated 123 billion tons of carbon in its trees and soils. If large parts of the rainforest die off and are replaced by savanna, this stored carbon would be released into the atmosphere, significantly accelerating global warming. The Amazon could flip from being a carbon sink to a massive carbon source, creating a dangerous feedback loop that would have global ramifications. Studies have even suggested that the complete deforestation of the Amazon could lead to reduced rainfall in the coastal northwestern United States and a significant decrease in the snowpack of the Sierra Nevada mountains. Finally, the consequences for the people living in and around the Amazon would be severe. Indigenous communities, who have lived in harmony with the forest for centuries, would see their cultures, livelihoods, and very existence threatened. The loss of the forest would also impact the health and well-being of a wider population, with potential for the spread of infectious diseases and the degradation of freshwater systems. While the situation is dire, there is still hope. The fate of the Amazon is not yet sealed, and a concerted effort on multiple fronts can help to avert the tipping point. The most immediate and critical action is to halt deforestation. Recent successes in reducing deforestation rates in the Brazilian Amazon demonstrate that with strong political will and effective enforcement, progress is possible. These efforts need to be sustained and expanded across the entire Amazon basin. This includes cracking down on illegal logging and land grabbing, and providing economic alternatives to destructive practices. In addition to protecting the remaining forest, large-scale reforestation and ecological restoration projects are essential to begin healing the damage that has already been done. Initiatives like the Reforestera project in Brazil and efforts by organizations like Amazon Conservation are working to reforest degraded lands with native species. These projects not only help to restore the water cycle and sequester carbon, but also provide economic benefits to local communities through payments for ecosystem services. The goal of reforesting millions of hectares of land is ambitious but crucial for the long-term health of the Amazon. Indigenous peoples are the most effective guardians of the Amazon rainforest. Their ancestral territories are consistently shown to have significantly lower rates of deforestation than other areas. Supporting indigenous communities by formally recognizing their land rights, providing legal and technical assistance, and empowering them to monitor and protect their territories is one of the most effective strategies for Amazon conservation. Forest-friendly livelihoods, such as ecotourism and sustainable agroforestry, can provide economic alternatives that align with conservation goals. Of course, the fate of the Amazon is inextricably linked to the global climate. Reducing greenhouse gas emissions in line with the goals of the Paris Agreement is essential to mitigate the impacts of climate change on the rainforest. This includes transitioning away from fossil fuels and investing in renewable energy. Finally, continued scientific research and monitoring are vital to better understand the complex dynamics of the Amazon ecosystem, refine predictions about the tipping point, and guide conservation efforts. Projects that track deforestation and degradation in real time, such as the monitoring of the Andes Amazon project, provide invaluable data for policymakers and conservation practitioners. The flying rivers of the Amazon are a testament to the intricate and powerful connections within the natural world. They are a reminder that the health of this vast rainforest is not a localized issue, but one of profound global importance. The looming threat of the Amazon tipping point is a stark warning of the consequences of our current trajectory. Allowing this vital ecosystem to unravel would be a planetary-scale tragedy. The time to act is now, with a collective and unwavering commitment to protect the Amazon, its flying rivers, and the future of our shared planet.